Hello, welcome to Lesson 5e on direct, inverse, and joint variation. We're first going to explore what direct variation and inverse variation really look like by looking at some examples. So what happens to the area of a rectangle if the width is always 2 and the length increases? We want to make a table and graph it. So remember, guys, area of a rectangle is length times width. Well, if my width is always 2, that means my area is going to be length times 2. So let's make a chart and see what happens. My chart, I'm going to plug in different lengths and see what kind of areas I get out. I'm going to look at lengths of 1, 2, 3, and 4. And then I'm going to look at the resulting areas. And now I want to graph this relationship to see what it looks like. And when I graph it, you can see we get a pretty steep straight line. Basically, as my length increases, my area also increases. And so we would say that the equation for this graph is linear. It is said that that the area varies directly as the length, and that 2 is my constant of variation because that constant 2 is in all of this. The area is always twice the length. So let's take a look now at what inverse variation looks like. Now let's consider a rectangle with an area of 6. And I want to make a table with all of my possible combinations of lengths and widths. So think about that again. Area equals length times width. Well, now 6 equals length times width. So now I want to consider, given what lengths we have, what widths can we output? So basically think about factors of 6. So if my length is 1, to get to 6, my width must be 6. And if my length is 2, my width must be 3 because 2 times 3 equals 6. If my length is 3, my width must be 2 because 3 times 2 equals 6. 4 isn't a nice number, 5 isn't a nice number for this, but 6 is. If my length is 6, 6 times 1 gets me an area of 6. So let's graph that. When I graph that, I don't get a straight line. This time I get something that's more of a curve. Basically, as my length increases, my width decreases. And we would say that the width varies inversely as the length. The quantity that is constant, in which case that would be the 6 here, is called my constant of variation. So let's look at some examples here. If I say that y varies directly as x, then my equation of variation would be y equals kx. That's a linear relationship, right? As y goes up, x goes up. Whereas if y varies inversely as x, we would say y equals k over x. As x goes up, y is going to go down, and as y goes up, x goes down. Note, pay attention to the change in variables such as the square root of x or the cube of y, because you'll see some interesting things in these. So let's look at example 1. Y varies directly as x, and y equals 24 when x is 3. Find y when x equals 10. Whenever you have a variation equation, I always want you to work these in 3 steps. The first step is you take the givens right here. Boom, that's what I'm originally given, to find your constant. Find k. Because we're dealing with a direct variation equation, I'm going to say y varies directly as x. Okay. Plug in your givens. We have 24 for y equals k times 3. Now we're going to solve for k. Divide both sides by 3 to get that 8 is k. So you found the constant of variation. Now I want you to write the equation of variation with your k plugged in. So that's going to be y equals 8k. That's my equation of variation. And my third step is you solve for what they're asking for. Find y when x is 10. I'm going to switch different colors so you can see what this looks like as a step. Find y when x is 10. So y equals 8 times, oh, I wrote this wrong back here, guys. Pause right here. Your k was 8 and your x is there still. So find y when x is 10. So y equals 8 times 10. That means y is 80 is your final answer. Okay, so those are my 3 steps. Step 1, step 2, step 3. Let's look at another one. P varies inversely as C. So let's write what that looks like. If we vary inversely, it's P varies inversely would be K over C. If P is -6 when C is 3, so I'm going to find my K. P is -6 when C is 3. To solve for K, I'm going to multiply both sides by 3 to get -18 equals K. I've done step 1, I've found K. Now I'm going to do step 2, I'm going to write my variation equation. P equals -18 over C. Now find P when C is -8. So I'm going to solve the problem. I don't know P, but I do -18 divided by -8. This is just going to reduce. It's not going to actually divide out. 2 goes into both. So I get 9/4 is my value of P. All right, let's go to the next page. So y varies inversely as x. If y equals 2 when x is 100, find y when x is 1,000. So first, I want to write my basic equation. Y varies inversely, that's k over x. If y equals 2 when x equals 100, now use that information to find k. Y equals 2 when x is 100. Find k. Multiply both sides by 100 to get 200 equals k. I've got k. Now write out your basic equation. Y equals 200 over x. Now we're going to find y when x is 1,000. Y equals 200 divided by 1,000. That reduces to y is 1/5. All right, guys, I want y'all now to do this. Try me. All right, guys, take a look and check your answer. Okay, let's look at another one. This is where our variables get a little bit more complicated. If n varies inversely as the square of e, as the square of e, let's write that out. N varies inversely means we have k over the square of e. That means we're going to have e squared. Okay, so that's my basic empty equation. When n equals 5, and n equals 5 when e is 2. So 5 equals k over 2 squared, or 5 equals k over 4. So 20 must be k. That means that your equation of variation is n equals 20 over e squared. So we've got the constant of variation and the equation of variation. Now find n when e is 10. So n equals 20 over 10 squared. N equals 20 over 100, or n again equals 1/5. All right, let's move right along then, shall we? There's a try me. I want you guys now to work this one out on your own. All right, please go ahead and check your answer. Okay, let's look at an example or some examples where these might show up in word problems, and that's actually the most common use for variation equations are in word problems. The weight of a load of bricks varies directly with the number of bricks in the load. So let's write that down. The weight of the bricks varies directly, that's k times the number of bricks in the load. I'm going to call that n. W equals k times n. If a load of 500 bricks weighs 1,175 pounds, so W is 1,175 pounds equals K times 500, what will a load of 1,200 bricks weigh? Well, let's go ahead and find K. Divide both sides by 500, and when I do this, that's going to reduce. I'm going to get the reduced fraction, which gets me 47 over 20. That's my constant of variation K, which means that my variation equation is weight equals 47 over 20 times the number of bricks. I want to know what will a load of 1,200 bricks weigh? Plug it in. Weight equals 47 over 20 times 1,200, which is 2,820. So 2,820 pounds would be my final weight. All right, guys, y'all have a try me. Go ahead and do it on your own. All right, guys, you should have gotten $40. Take a look at your work and check it. Let's go on to the next. All right, we also can have a thing called joint variation. So we say if y varies jointly with m and n, we would write y equals k times m times n, where k is your constant of variation. And again, we're being careful with changes of variables. And joint variation just means that you have multiple things varying directly together at the same time. So in the constant of variation, find the constant of variation in the variation equation. P varies directly as t and inversely as the square root of v. So we have two things happening here at once. Even though there are two things happening though, there's only one constant. So it would be P varies directly as t, so k times t, and inversely is the square root of v. Inversely means we throw in the fraction bar, and we've got the square root of v. So that is your basic equation. We're now going to plug in all of these values to get our constant of variation. So P is 10 when we don't have K yet, but T is 2 over the square root of 25. I'm going to simplify this to be 10 equals K times 2 over 5, multiply both sides by 5 to get 50 equals K times 2, divide by 2 to get that 25 is K. That means that constant of variation is 25. And now my variation equation, I got to plug the constant back in. It's going to be P equals 25t over the square root of v. And that is my final answer. All right, let's look at the next one. The lateral surface area of a cylinder varies jointly as its radius and its height. So my lateral surface area of a cylinder, I'm going to call that L, varies jointly, so K times its radius and its height. Express the surface area S, oh, sorry, they said S. Let me change my variable there, guys. Sorry about that. Surface area S in terms of R and H. Well, that's my equation. I don't have anything else to do. They just wanted this basic equation expressed. And there it is. S equals K times R times H. The area of a regular polygon varies jointly as its apothem and its perimeter. So express the area in terms of apothem A and perimeter P. So area of a regular polygon varies jointly, means it gets K times its apothem A and its perimeter P. Just basic setup of the equation. All right, let's take a look at this guy. We have a full one to solve. I want y'all now to do this try me on your own and have a go. All right, guys, go ahead and check your work. Again, we've got the constant of variation here, the equation of variation here, and this one did something a little bit different because it wanted us not to find R, but instead to find one of my variables that was inside my equation to find S, which we can still do, and we actually were able to do that at the end of the day. All right, let's look at some word problems. The volume of a gas of a given mass varies directly as its absolute temperature and inversely as its pressure. So let's write that. Volume of a given mass varies directly as its temperature and inversely as its pressure. At 2 degrees C and a pressure of 99, oh wow, I don't know a pressure of 99, 4 grams of helium occupies 23.1 liters. I'd like to point out, guys, that the 4 grams is actually not necessary in this problem because you don't need to know you don't need to know mass for this. You only need to know volume, temperature, and pressure. What is the volume of helium at 27 degrees Celsius and 121? So what I'm going to do to solve this, I'm going to multiply both sides by 99, then divide by 2 to get my K. And I get 1,143.45 is K, which means that my equation is volume equals 1143.45 T divided by P, temperature divided by pressure. I now plug in, I'm still looking for that volume. Volume equals 1143.45 times 27 divided by 121. We're going to do that in our calculator real quick. And we get 255.15 liters. All right, here's our last question, guys. The maximum weight that a circular column can support is directly proportional to the fourth power of its diameter and inversely proportional to its square of its height. So let's go through that. The weight that a column is directly proportional, it's K times the fourth power of its diameter to the fourth power, and inversely proportional to the square of its height, so height squared. Great. A 2-meter diameter column, so K times 2 to the fourth, that is 8 meters in height, can support 1 ton. We're going to use that now to find K. So I have 1 equals 2 to the fourth is 16 over 64, which actually reduces to be over 4. So it'd be K over 4, which means that 4 is the value of K. So that means that your equation is W equals 4 times diameter to the fourth power divided by height squared. And now I'm going to find the weight that a 1 meter in diameter, so weight that a 1 meter in diameter column to the fourth power, boom, that is 4 meters high can support. So working that out, that ends up being 4 over 16 or 1/4, and this is in tons. So that is my answer. All right, guys, welcome to the end of the video. Please take a look at your practice assignment and we'll go over this in class. Thank you guys so much.